Okay, I want us to continue our lesson. The last time we met, we were learning about alcohols, and we spoke about 3 different types of alcohol. And the first alcohol was the primary alcohol, secondary alcohol, tertiary alcohol. The primary alcohol, it's alcohol whereby the hydroxyl group OH is bonded to a carbon which is bonded to only one carbon. Secondary alcohol, OH is bonded to a carbon which is bonded to 2 other carbons. Tertiary alcohol, OH is bonded to a carbon which is bonded to 3 other carbons. So I can give you this one. Can give you this one. I want you to tell me if it is, what type of an alcohol is this one? Is it a tertiary alcohol, secondary, or primary alcohol? What is the name of this alcohol?
Secondary alcohol.
You are calling it a secondary. Oh, it's a secondary alcohol. Why? Because the OH is bonded to a carbon which is bonded to how many carbons? 2 other carbons, right? Can you be able to give me the name of this alcohol? Right on your lap. Let me see if you'll be able to get it. We count the longest carbon chain, right? 1, 2, 3, 4. Actually, let me even add it. Let me make it to be like this. 1, 2, 3, 4, 5. Wow. 1, 2, 3, 4, 5. What does 5 mean? 10. So this one is 10. Star? No. We write pentanol, right?
Yes.
But I told you that we are not supposed to just write pentanol. We need to indicate where the OH is, right? So this one will become pentan 2 all. Is it correct?
Yes.
Why are you saying one? The OH is here. OH is at carbon number 2. These 2 represent the position where the OH is. Do you agree with that?
Yes.
You agree with it, right? Do you also understand what I did? Do you also understand?
Yes.
Because you do not have to agree with things which you do not understand. If you don't understand something, you need to tell us so that we can be able to show you, right? Yes. That's what needs to happen. So now, I want you to give me the name of this one. I want you to give me the name of this one. Can you be able to give me the name of this one? Give its name. Okay, I hope by now we have given the name of that one. What I want to demonstrate to you is that the things which, the structures which are drawing, it exists in liquid form. You see what I'm holding?
Yes.
Can you see what I'm holding? I'm holding methanol and what? And ethanol, right? I'm holding methanol and ethanol. What I'm holding is what? Alcohol. This alcohol is in liquid form. This alcohol is in liquid form. So I'm holding methanol and ethanol. So if I can take this alcohol, liquid form as it is, and I put it inside a beaker, and I put water, you can see that we have got Bunsen burners, right? You see the Bunsen burners that we have. I start to boil maybe methanol, and I want to compare it with water. The Bunsen burner will just evaporate immediately. It will not take just a lot of time. It is highly flammable. You understand?
Yes.
Alcohols are highly flammable. So the structures which we are drawing is not solid things, it's liquid. There's a liquid here. You understand? There's a what? There's a liquid inside this. We're going to do experiments. So what is the name of this one? We find the longest carbon chain. 1, 2, 3. 1, 2, 3. So it's 3, 3. Can you see?
Yeah.
Starting from all directions, we discover that the longest carbon chain is what?
3.
Is 3, right? So it means this one is, what does 3 carbon mean? This is prop, right? It means the name of this one, the name of this one, we're going to call it propan, right?
Yes.
Then, where is the double bond? Where, I know the double bond. Where is the OH? Where is OH? Carbon number 2. We are making this one to become the longest carbon chain. So it's going to become propan 2-ol. Right? Are we done?
Yes.
No, we're not done. Look where the branch. Can't you see? Well, the longest carbon chain here it is, but we've got the branch. That branch, we call it a what? What do we call the branch? Alkyl group. Our alkyl group has got how many carbon? 1. What is the name of one carbon? What do we call it? So I'm going to write what here? I'm going to write the branch is where? Where is it? So it means I'm going to write 2-methyl. So this one is 2-methyl propan 2-ol. Do I have people who got it? Do I have people who got it? It's what? 2-methyl propan 2-ol. 2-methyl propan 2-ol. You understand, right?
Yes.
Okay. I'm happy that you do understand. I'm happy that you do understand. As I've told you that we give the functional group a preference. Do I have people who struggled to get this? Can you please show a hand? The people who struggled, all of you, those who struggled, don't be afraid. Hand up, I want to assist you. Why do you do that? We're moving forward. We are moving forward. So now let me erase this. Is this a primary or a secondary alcohol or a tertiary alcohol? It is a tertiary alcohol, right?
Yes.
Because OH is bonded to a carbon which is bonded to 3 other carbons. This carbon is bonded to this one, and this one. So this one is a tertiary alcohol. In the lab, we cannot burn alcohol directly. We cannot burn. You see here, I'm holding ethanol. I cannot burn ethanol directly. I cannot burn what? Ethanol directly. I'm going to put it inside the test tube, then I create a water bath. I put water in the beaker, then I put the test tube which contain ethanol. So that, what am I doing? Why am I doing that? Why am I not burning ethanol directly? It is highly flammable, right? It will evaporate fast. So we're avoiding that because we want to do something with it, né? It will evaporate fast. Okay. Okay, my people. I want us to continue. Just one last thing. Oh, okay. Can you be able to draw the structure of ethanol for me? Draw ethanol. I'm holding ethanol. Yes. Can you please draw the structure of this ethanol? I'm holding ethanol. Draw ethanol. Draw ethanol. Draw ethanol. Can you be able to draw ethanol? Yes, draw ethanol. The very same thing which I'm holding here. Draw the structure of ethanol. Please. Draw ethanol. Draw ethanol. Draw ethanol. Draw the structure of ethanol. Are you done? Yes. Are you done? Yes. Please show it to us. Show it to us, that structure of ethanol. Show it to us. Show us the structure of ethanol. It's correct. Show us the structure of what? Ethanol. Yes, it's correct. Where's yours? I'm sorry. Where's yours? Yes, it's correct. It's correct. Where's yours? Where is it? No, but yours have got many carbon most. How can that be ethanol? No, it means you even understand. You even understand, eh? Okay, I want you to draw the structure of a what? Of a butanol. Butanol. Let me see. Let me see yours. Can you please turn it? Where is it? But. Is that a but? You forgot. This is a prop. Is this what's? Go and check your notes. What's a but? What does a but look like? How many carbon does it have? This person forgot. You see? You see now? Can you I see? Can you please turn it? Are you done? They've got 4, right? Yes, it's a prop, that one. Can I see yours? Where is it? Oh, here. Here. Yeah, it's correct. Can I see yours? It must have 4 carbon. 4? 1, 2, 3, 4? Yes, it's correct. But I hope you are noticing that I'm saying it's correct, but they look different in terms of the position of OH. Do you agree? Yes. I'll tell you why. I want to introduce a concept. Where is it? It's correct. Where's yours? Where's yours? It's correct. Where's yours? It's correct. Where's yours? Yes, it's correct. Where's yours? Yes, it's correct. It's a butanol. But I want to introduce something to you. I want to introduce something to you. Okay, thank you guys for drawing the correct structure of butanol. Butanol, I want to introduce something. That's why I said draw butanol. If you compare, someone can draw butanol like this. Someone can draw butanol like this. Right?
Yes.
But someone is not going to draw it like this. But it's still gonna be butanol. Someone can draw butanol like this. Someone can draw it like this. Can draw it like this. Is it correct? Yes. Someone may not draw it like that. Someone may draw butanol like this. Right? Someone may draw it like this. That's why it's very important for us to understand the nomenclature of these things, right? I want to introduce a particular word. As I've asked you that, compare your drawings. I want to introduce to you what we call structural isomers. What I call what? Structural isomers. I want to introduce structural isomers. You could see that I said draw butanol. And when you look at it, I even said it's correct. But when you compare with the one of your friend, it is different, right? So, that is because what you drew, they are structural isomers. What is a structural isomer? An organic molecule. An organic molecule with the same organic molecules which have got the same molecular formula. The same molecular formula, but different structures. Structural formula. Do not be shocked by the structural formula. This simply means the structure, right? Because you will think about the formula as if it's in maths when you write the formula. The structural formula, they mean what? The structure. Like what you just drew. When you compare with your friend, they appear to be different. It's because they are what? Structural isomers. You understand? What do I mean? Their molecular formula is carbon. How many carbon did they have? 4. Hydrogen, how many did they have? How many? 9 hydrogens, right? And oxygen, how many? What you drew, it has got this molecular formula, right? But their appearance were different, right? It's because they are what? Isomer. Structural isomer. They've got different structures, right? Yeah. But they've got the same what? The same molecular formula. You need to take note of the structural isomers. Structural isomers. We have what we also call, hello? We count it. So it's about 10, eh? Yes. We have 10. Someone said 9, so you could not count. You can't count. Someone said 9. Isn't it? It's even if it is bonded to O, it is hydrogen. Is it not hydrogen? Yes. It is hydrogen, right? Yes. So we need to count it. Okay. Blessing. You are lost. You are lost in which way?
So when you wrote C4H10O.
C4H10O is just a molecular formula. C stands for carbon. C just represents what? Carbon. Then H, it represents hydrogen. O, it represents oxygen on the butanol that we're talking about. How many carbons? 4. How many hydrogen? 10. How many oxygen? 1. So that's what it means. You understand now? Okay. It's a molecular formula. You remember last year when we were doing grade 11, I told you about what? Molecular formula, right? Are we okay?
Yes.
Okay. That's why I'm saying that what you drew, that's why it appeared to be slightly different with what your friend drew. It's because they are structural isomers. They have got the same molecular formula. Then we have this one, my people. This one is called positional isomer. Positional isomer. These definitions are examinable, so you must know them. What are positional isomers? They have got the same molecular formula. Same molecular formula, but different positions of the side chain. Side chains, substituent or functional group on the parent chain. Do you understand that one? Positional isomer, it means the branch they are not in the same position. You understand? The branch are not in the same, or the functional group are not in the same. It means the one which we were doing just now after, it is a positional isomer. Did you see it? Because the OH is not in the same position. Do you agree? Look at this one, guys. Look at this one. OH. Do you see this one? Do you see where OH is? Then I draw another one. I draw another one. Do you see where OH is on this one? The first one is at carbon number 2. Then the second one is at carbon number 1. So they are what? They are positional isomers. Because their functional group are in different positions. You understand? Yes. Okay, positional isomer, same molecular formula, but different position of the side chain substituent or functional group on the parent chain. So these ones, they differ in terms of what? Position. You find that it has got a branch. One branch is at carbon number 2. On the other, the branch is at carbon number 3. So we are going to call them what? Positional isomers. Quickly, I want us to talk about what we call aldehydes. It's another series. It's another homologous series. It's another homologous series. Please, in the exam guideline, go and look at functional isomers. Isn't it I gave you the exam guideline? Go and study functional isomers. Functional isomers, same molecular formula but different functional group. Same molecular formula but different functional group. It's cheap, this one, right? Functional isomer, same molecular formula but different functional group. It's just that for now I cannot be able to demonstrate. I cannot be able to demonstrate because I've been taught you a homologous series which I'm going to introduce functional isomers. You will see when we're doing after doing the ketone and the aldehyde, then I can introduce that. Because for now, you do not have the functional isomers. The molecular formula is the same. They are same amount of hydrogen, same amount of carbon, same amount of oxygen, but their functional group is different. You find that the other one has got another functional group, then the other one has got a different functional group. So I want us to do what we call aldehydes. I want us to do what we call aldehydes. These aldehydes, they are very, very interesting. The aldehydes are what? Very, very interesting. Okay. The aldehydes. The aldehydes. Aldehydes. Okay. I want us to start with the what? The aldehydes. The structure of the functional group which we find in the aldehydes is carbon with double bond, oxygen and hydrogen. Then, do you see those lines?
Yes.
No. Carbon is bonded to 5, right? And it is impossible, right?
Yes.
Meaning that we need to have how many? 4. You know that carbon can only bond to what? 4. I told you that whenever you write how many? You write 4. Just know that you are out of order. It's incorrect because carbon is in short of 4 electrons, right? So it can only create how many bonds? 4, right? So here is bond number 1, number 2, number 3, number 4. So this is the structure of the functional group which we find in the aldehydes. You understand? Okay. Remember that the functional group which we find in alcohol is called what? What do we call it? Yeah, it's OH, but the name, its name. You are right, it's OH. What do we call it? Hydroxide group, right? Huh? Yes. So the structure which we find under the aldehydes, can I tell you what we call it? We call it the carbonyl group. We call it the what? We call it the
Carbonyl group.
We call it the carbonyl group. We call it the carbonyl group. So, carbonyl. So, the suffix of the aldehyde is what? Is R. A-L. I told you that from alcohol going upwards, we are going to introduce Al to the longest carbon chain, right?
Yeah.
Don't forget the Al. So the suffix of the aldehyde is what? R, right? The suffix for these ones is what? R. And I must teach you first so that I teach you aldehyde and ketone at the same time, because if I can teach them separately, you are going to confuse them because they look the same. They look the same. The difference is where this double bond is. Under aldehyde, it has got double bond oxygen to the first carbon. It has got double bond oxygen to the first carbon. Aldehyde has got what? Double bond oxygen to the first carbon. Is it okay?
Yes.
Okay. So now, let me erase. Let's say I draw this. 1, 2, 3. Can you see this? This one is an aldehyde, right? How do we see that it is an aldehyde? It has got a carbonyl group. Carbonyl group. Carbonyl group, it means double bond oxygen and a carbon, right? It has got the carbonyl group. This is the carbonyl group. This is the structure. They can ask you to draw the structure of the functional group of aldehyde. It is the carbonyl group. Carbonyl group. Can you see it? Is C bonded to hydrogen, double bond, oxygen. Hydrogen, 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 hydrogen. Can you be able to see that? This one is carbonyl group. This one is carbonyl group. We find it in aldehyde and the ketones, you'll see. This one is an aldehyde because this double bond of oxygen is in the first carbon. Let us give the name of this one. How many carbon? 1, 2, 3. What do we call 3 carbons? Huh? That man is always making mistakes. He's always saying, he's confusing pent and pro. And sometimes I also used to do the same, whereby I confuse pent and pro because they all start by P. But just know it's pro, man. Pent have got 5 carbons, right? Yes. So this one we're going to call it prop. We add the AN, you remember? So it's propan, right? We add the AN. I told you that from alcohol going upwards, so everything that we'll do, we'll add what? AN, right? Because these ones, they are not hydrocarbons, right? They are not hydrocarbons. So now, propan. Propan. We're not done giving the name of this one. Remember, we do it bit by bit. We don't rush, right? So, what is the suffix of this one? It's R, right? So this one is propanal. That one is what? Propanal. That one is called what? Propanal. We don't do those things of indicating the position of double bond O. Don't make that mistake. You write it as it is. Propanal. Because the position will always be 1. The position will always be 1. Position will always be 1. The position will always be 1. That's why I've been telling you that I must teach you this one and ketone at the same time. This one is propanal. Let me show you another one. Are you okay? Yes. You're okay, right? Can we be able to give the name of this one? Let us count. Let us check which one is the longest carbon chain. Let us start here. 1, 2, 3, 4, 5. Well, got 5, right? Remember, we don't start from one place only. We check around, right? Let's see from this side. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5. Then 1, 2, 3. We know that it's either we choose this one to be the longest carbon chain or this straight one. We just choose. It will give us the same thing. Am I lying? No. Because the longest carbon chain, parent chain, will go down in carbon 5. So it means we can choose this one if we want. Or we can choose a different one. We can choose this one if we want. All of them, they've got 5, right? Let us choose the one in red. 1, 2, 3, 4, 5. What does 5 carbon mean? 10. The way in which we name, we do it somehow. We do it bit by bit. It means we're going to have pentan. Where is the double bond oxygen? Is it in the first carbon? Where is it? It is in the first carbon. Can you see? Yes. We're going to have a problem here, right? We're going to have a problem, right? Yes, I see. We're going to have a problem. Do you hear me? Yes. Let us erase this thing. Let us erase this thing. Let us not exhaust it. What, it is not examinable with a branch. It is not examinable with a branch, right? Just confirmed with the exam guideline. We don't want to teach you things which will not be examined. No? Just choose a good. We don't want to learn things which are not supposed to be learned. Okay. Let's just give the name of this one and we'll learn about ketone quickly to avoid confusing ourselves. 1, 2, 3, 4, 5. 5 is what? Pentan, right? Where is the double bond oxygen? First carbon, can you see? Yeah. So it's a ketone, right? So this one is pentanal. It's pentanal, right? It's pentanal. Do you agree? Yeah. This one is pentanal because it has got 5 carbon and the double bond oxygen is in carbon number 1. It's pentanal. Is it okay?
Yes.
Okay. Let's quickly move to ketone. Because they behave the same, these things. Ketone. Ketones. I want us to do the what? The ketones. I want us to do the ketones. I want us to do the ketones. I want us to do the what? The ketones. So the structure of the functional group of ketones is carbon, double bond O. Some they write R here, R, to show that we are continuing with in terms of carbon. We can write it like this. Do you see this? This is the functional group of the what? Huh? Of the ketone. This is the functional group of what? It tells you that double bond oxygen is not in the first carbon. You see, that's why this double bond oxygen is bonded to a carbon which is bonded to what? Two other carbon. It is not in the first. It is not in the first carbon, right? It can be anywhere, but not in the first carbon. It can be anywhere, but not in the first carbon. Eh? You don't understand, eh? Let me explain. Let me concentrate. Ketone, ani, hambani na aldehyde. Imaka ka ketone, double bond ya oxygen. Aileka carbon number 1. Inga carbon number 2, number 3, mara hai number 1. Did you understand? Yeah. You see, this double bond oxygen is not here. With aldehyde, the double bond oxygen is always here. But with these ones, double bond oxygen is not at carbon number 1. With ketone can be anywhere except carbon number 1. Can be anywhere. So this is the functional group, right? So let me just draw the structure for you. Let me just finish this one. But this is the functional group. They can request you draw the structure of the functional group of a ketone. You must draw this. So let me just finish this one. Okay, suffix. Suffix of ketone, can I tell you? Yes. Is 1. Suffix of ketone is 1. It means you just write 1. Suffix of ketone is 1. So remember I told you that we'll add the AN to the longest carbon chain, right? To that name. So how many carbons do we have here? 1, 2, 3. We have 3 carbons, can you see? Yes. What do we do? It means this one we'll call it prop, right? Propan. What is the suffix of this one? 1, right? So it will be called propanone. So this one is propanone. Propanone, proper 1. Propanone. So this one is called propanone. You understand? Yes. Yes. Can you? Oh, let me just give you another example. I just want to confuse you a bit. Tell me, is it a ketone or an aldehyde? It's an aldehyde, right? Yes. Why? Because double bond O is in the first. If we can put this carbon anywhere, we put it here. Double bond O. H. What is this? Is it a ketone or aldehyde? The ketone, because double bond is not at carbon number. Wow. What is the name of this one? 1, 2, 3, 4, 5. 5 is pent, right? Yes. So this one is pentanone. You understand? Yes. We are left with 2. I will finish. We are left with 2. We are just learning their general characteristics. We are going to come back and talk about deep things, about the intermolecular force. Okay, thank you guys. Thank you very much.